This is a lesson on designing experiments, and it reviews important vocabulary. Okay, you can see here 3 trays full of soil. They've got a waterer hanging overhead where you can adjust the water amount. They've got lights hanging overhead where you can turn on or off the lights. You turn them all off. There's soil in each of the trays, and each of the trays have a little heater underneath where you can adjust the amount of heat that they each get. We're also given 3 different kinds of seeds that we could use. All right, if you were a scientist ready to do some germinating experiments, you could ask all kinds of questions, and that's the first step that you do in designing an experiment. You need a question that will lead you to do an experiment. So I might want to know, what is the effect of lights on how well seeds germinate? Or I might want to know, what is the effect of different amounts of water on germinating seeds? Or I might want to know what the effect of different temperature is on germinating seeds. Or I might want to know how different types of seeds germinate. Okay, so it's really important in an experiment. The scientists can only test one thing at a time. They can only have one question at a time. Otherwise, the data ends up getting jumbled and you don't know what the results mean. Okay, so I need to choose one question that I'm curious about. So I'm going to choose the heat. And my question is, what temperature soil will lead to the most seeds germinating? What soil temperature is the best for seed germination? Okay, that's my question. Step number 2, I want to design an experiment around that. And so what I need to do is to answer my question in the form of a hypothesis. And as you probably know, a hypothesis is an educated guess. So I need to use all my background knowledge and everything that I know about seeds and plants and come up with the best answer to my question. So I think probably a medium amount of heat is best for seeds to germinate. So my hypothesis is going to be, if the soil temperature is medium, then the most seeds will germinate. Okay, so once I have a hypothesis, I'm pretty much ready to go. Then I can design my experiment. So I have chosen my independent variable to be temperature. Okay, and the independent variable is this one thing that you're testing in the experiment. When you do an experiment, you can only test one thing at a time. If you test the effect of water and the effect of lights and the effect of different seeds and temperature all at once, you're not going to be able to keep straight what exactly happened, and you're not going to get a clear answer for your hypothesis. Okay, so my independent variable, the one thing I'm choosing to test, is temperature. Okay, so I'm going to go with that, and that is in my experimental group. So I'm going to say, I'm going to make group 1 my medium temperature. Okay, so group 1 is my experimental setup. That's my experiment. I'm having group 1 be the test of my hypothesis. So as you probably also know, in an experiment, you need to have your experimental groups and you need to have one or more controls. And the control setup is where you keep everything the same as your experimental setup, except you don't have the independent variable there. Okay, so I've got these 2 other groups. I'm going to make both of them my control groups, and I need to make them identical to my experimental group, except I don't have my independent variable there. So we said my independent variable is a medium temperature, because that's what my hypothesis says. My hypothesis says it's the medium temperature that's going to be best. So my controls are going to not have a medium temperature. So I'm going to set one of these at high, and I'm going to set the other one at low. Or I could keep both of them high, for example, or I could keep both of them low. But the point is, my control needs to not have what I'm doing in my experimental setup. Okay, so for this experiment, I'm deciding I'm going to have this low, and I'm going to have this one, or rather that's high, and this one's low. And otherwise, everything else needs to be constant. I need to keep all the other variables, all the other things that could be changed, I need to make them not change. I need to make them constant. Okay, so if I'm going to have the light on here, I better have the light on here, and I better have the light on here. I'm not looking at what the effect of light is, so I'm just going to leave the light on. Okay, if I have water set at 50 milliliters here. I better keep water set at 50 milliliters here and here because that is constant. I'm not looking at the effect of water on seed germinating, so that's constant. Okay, I am looking at temperature. That's my independent variable, so that is going to change. That is medium here, and I'm keeping it high, and I'm keeping it low here. All right, now I need to decide on my seed use. I am not doing an experiment about different kinds of seeds, right? I'm doing an experiment about different temperatures. So that means I have to use the same kind of seed for all three setups. So I'm just going to go with seed A. I'm going to put seed A in my experimental setup, seed A in my two control setups. All right, so now I'm ready to do my experiment, okay? So I've completed step number 2, which is designing my experiment. I have my independent variable, I have my constants, I have my experimental setup, and I have my control setups. I've not yet said what my dependent variable is. So the dependent variable is what the scientist thinks depends on the independent variable. It's the thing that the scientist thinks is going to happen. It's the thing that the scientist is going to collect data on. So I always like to think dependent variable starts with a D and data starts with a D. So the dependent variable is the data in this experiment, and the data is the number of seeds that sprout, right? Because my hypothesis is if the temperature is medium, then what depends on that? The number of seeds that sprouts will be the most, okay? So dependent variable depends on the independent variable. So in this case, the dependent variable is the number of seeds that sprout. Okay, so I am now ready to move on to step 3, which is collect data, which means I need to finally do my experiment. So I've got my experimental group here and my two controls here, and I'm going to start the clock. Okay, and it looks like the experiment is going to go through day 5. They're starting to sprout, and at the end of day 5, they have stopped sprouting, and I can look and collect data and see that at a medium temperature, I have 18 seeds sprouting. At a high temperature, I have 16 seeds that sprouted, and at a low temperature, I have 20 seeds that sprouted. Okay, so based on this trial run of the experiment, it appears that my hypothesis was not correct. It appears that a low temperature is best to get the most seeds to sprout. Okay, but being a good little scientist that I am, I'm going to repeat my experiment. You want to have lots of trials, because the more trials that you have, the more likely it is that you're going to collect good data. So I'm going to start the experiment again. Notice the seeds are going to start sprouting around day 2, but my question was not which seed or what temperature leads to the seeds sprouting the quickest. My question was, what temperature leads to the most seed sprouting? Okay, so it's really important to be really clear with what your question and what your hypothesis is so that you're collecting data to really answer that question. So that's why I'm having this experiment run all the way to the end so I can see which temperature leads to the most seed sprouting. All right, let's do it again. Okay, all right, in trial 2, same results as last time. The low temperature gave me the most seed sprouting. All right, so I'm done collecting data. Now I'm ready to analyze the data. So this is where I would look at all my different trials. I would compare my experimental group to my control group. I would compare and contrast. I would look for patterns, and I'm probably writing some kind of a report. And so I would write some sort of paragraph that explains it. I might include a table. I might make a bar graph showing this information. And then your last step, step 5, is to draw a conclusion. And my conclusion is going to be that my hypothesis was incorrect. It appears that the low temperature is best if you want to sprout the most seeds.